Alright, so we got a guest teacher. He's going to explain what the order should be in terms of what's the highest boiling and melting point, what's the lowest, and why.
I gotta tell why?
Yeah, you got to tell why. Do it.
Let's see.
Oh my gosh, do it.
I got stage fright.
What? Okay. I know, it's just a class. We were talking the whole class a while ago.
I did not know that, but clear my throat.
You can just point to what you think is the highest. Just point to it. What do you think is the highest?
Oh, point to one of the sides.
What do you
Okay,
think is the highest?
I can do this. It's Hey, shh, can you be quiet? A is the highest.
Does everybody agree that A is the highest?
Yes, I got.
What'd you say? Okay, so everybody but
Ryan Stanley. Ryan Stanley.
Okay.
That's what I said.
Ryan, why don't you come here and explain to everybody?
Oh.
It's from E to A. It's E to A.
Okay.
That's the order.
E is the highest. Explain it. Why?
I can't explain it. I just knew what it was.
Maybe so. All right, Michael, have a seat.
If you told me ahead of time,
All right. Okay, Nate. Why is E the highest and A is the lowest? Well, you said it was. You got more places for polarity to occur. You got more dipole locations on this one. Well, you didn't tell everybody when you were up here. Okay. All right. Shh. The more polarity you have, the greater the attraction between particles. The greater the attraction between particles, the higher the boiling point, melting point.
How do you know you got more polarity?
I have more. Summer's got it. The more OHs you got on something like this, well, all I have is a choice between hydrocarbon groups, and OH groups. The OH groups are polar. The more of those I have, the more attraction I have between this particle and the next one that's like it. So the higher the boiling melting point. Yes, it is in your packet. Okay? Now, using those groups I announced earlier, I want you to figure out whether there is any polarity, any dipole-dipole force in a structural particle like this one. All right? Figure out whether there's any dipole-dipole force between this structural particle and others like it. You can get in your groups now. Yes?
Matt King, let's go to that last.